OK, so what we're going to do is we're going to make sort of a piece of a poker playing game, right? So we're going to make something that will generate a hand. And here's where it gets kind of interesting. We're going to check a given hand for doubles and straights, right? So, well, doubles or triples or quadruples. So more than one of a given kind, or straights. So we're not going to deal with suits yet, right? So we're just going to have values of cards, just 1 through 13, right? Ace through king, right? But we will write some code that will tell us, like, there's 2 of a kind, there's 3 of a kind, there's a straight, right? So yeah, so that's what we will be building. So let's talk about vectors first. OK, so I'm going to clear this out a little bit. We've got a lot of stuff going on here. OK, so I'm going to include vector. Yeah. Sure.
Does like including algorithms or strings or vectors or any of these things, does that ever get to a point like where we're overwriting something like this?
Great question. So it's pretty safe right now, right? Because we're all just using the standard stuff, right? Yeah. But you're absolutely right that could be ambiguous, right? So like let's say we could deliberately implement something that redefined vector or something, right? So in that case, that's where the : operator becomes important, right? So it's the : is called the scope resolution operator, and yeah, we can always use that, right? So hopefully that's not really going to happen in what we do in class because we're just using standard library stuff. But you're absolutely right. It can be the case that you've got 2 definitions with the same name. And in that case, use standard : whatever, or my library : whatever, right? Although if you're writing something for yourself, I would just recommend using a different name. Anyway, all right, so let's do it. So vectors are cool in that they let us have variable length, right? So the example I want to work through is, let's say we're going to make something that generates a poker hand, right? So we're going to simplify cards just a little bit, and then we're not going to deal with suits, right? So what I'm going to define as a hand is a list of integer values mapped with each one being 1 to 13, right? So ace to king, right? So the first thing I'm going to do is I'm going to write a function that will spit out a randomized hand. And I'm going to return that as a vector. And the nice thing about that is I can request a hand of a given size. And I don't have to specify it until runtime, right? Because we can start out by having a hand that's a 5-card hand, right? But then we can easily go to a 7-card hand or whatever we want. We can have a 10-card hand, whatever strikes our fancy. All right, so well, just to show you this. So vectors, we saw how we make an integer array. So a vector is similar in that we say, my vector, right? So now notice I don't have a size in here, right? So it's just int, because vectors don't have a fixed size, right? So their size depends on what we've added to them so far, right? So okay. All right, so I'm going to make a function, vector int. OK, so it's going to spit out a new vector of type int, right? Or, I'm sorry, I shouldn't really say of type int. A vector containing ints is a better way to say it. So let's do that. OK, so I'm going to say vector int. Now what I want to do is I want to insert things into the vector. So one thing that is a little tricky is what we don't want to do is this. So I'm going to write it in a bad way, just to show you how not to do it. So I'm definitely going to say for int I equals 0, I less than hand size, right? So this is not the bad part, right? That's totally valid. So what would be bad, though, is if I was to do this. Let's say for now we're just going to have all aces, because we're cool like that. So the problem with that is this is a little tricky in that the square brackets absolutely works with vectors. Totally does. However, my new vector, right? So if we just look at this, how big do you think new hand is at the moment from that? Almost. What would that one thing be, though? Oh, right. So there's nothing in it, right? So it's empty, right? Which is totally fine, but it's of size 0. So if we directly index into it without adding anything first, we're going to have problems. So this should actually generate an error. So I'm going to go down here and I'm going to say, just to actually get this wired up, I'm going to say my hand equals new hand. What do I call it? Make hand, sorry. It was make hand 5. So let's say that, right? And this should blow up on me. Yeah. Oh, well, it blew up on me for a silly reason. So it complained because I didn't actually return it. So let me return new hand. There we go. OK. So this should blow up on me. Ah, there we go. All right. So we get debug assertion failed. And another thing you might see in this kind of situation is something that sounds really scary, a segmentation fault. And what a segmentation fault is we're reading from a bad part of memory. So I'll abort, right? So what's going on here so far is I've made a vector, and vectors are totally capable of handling, however many ints we want, but I haven't added anything to it yet, and I'm using the direct indexing in, right? So that's a problem. So what I want to do instead is I want to push stuff onto it, right? So one of the things that's built into the vector class is the push back method, which just tacks something onto the end, right? So the nice thing about that is we don't have to worry about how big it is right now, and it's always going to be safe to add something onto the end, right? So what I want to do instead is I'm going to say new hand. So not that. I'm going to say new hand. Push back. Notice this is where IDEs start to be really useful, right? So Visual Studio knows that we imported the vector library. It knows that this is a vector. So I hit dot, and I get nice suggestions that makes our lives easier. Right, so I'll push back 1. So again, so far we just have all aces, right? So now this is going to be fine. So if I build it now, it's totally fine. And nothing actually happens because I'm not outputting anything yet, right? So just to make things nice on ourselves, I'm going to implement a function to print a vector. So I'm going to say print hand, and I'll take in a vector containing ints. So I'll do something like, let's just say, OK. So this is totally fine to do. So I'm using the square brackets again, right? But it's OK, because I'm wrapping this in 0 to hand.size. So the problem before was just I was accessing something that happened to still be empty. And that was giving me out of bounds, basically, error. Here, it's not empty, right? If it was empty, if we passed in an empty hand, what would happen? What do you think? Would anything be printed if I passed in an empty hand? Kind of a trick question. Just guess. I'm not grading you on this. Yeah. Right, Isham? Well, like I said, it's kind of a trick question. And now this would get printed, right? Current hand would get printed. But yeah, but you're right though. So nothing would print, right? Because if it was empty, size would be 0. And so we'd say, we'd start out I equals 0. 0 is not less than 0. So just nothing would happen, and that would be fine, right? So it's totally fine. And so I'm going to get my hand, and then I'm going to print my hand. So I'm going to print hand, my hand. And we should get a bunch of 1s. So we get 5 1s. It's a pretty lucky hand. I'd be pretty suspicious if somebody had 5 aces. But, OK? So let's make this a little more interesting. And then I'm going to make it so that our hand actually has a randomized value, right? So in this case, what I want is I want a random number from 1 to 13. So you guys tell me how can I do that? I need some stuff here, right? So I'm gonna I'll do this. I'll int card value equals okay. So what do I need? For 1 to 13. That's 13, right? So Jack, 10, Jack, Queen, King. Yeah. Perfect. That's exactly what we want, right? So Naldon totally nailed it. We take rand, right, which gives us a random integer. We modulo 13, which gives us 0 to 12, right? Now, but since we want 1 to 13, we add 1, right? So totally correct. We modulo by the number of distinct values we want, but we have to offset it a little bit. So in this case, we just offset by 1, because 1 is totally valid in the context of cards. Also, we're assuming that we're representing ace as 1. We could also represent ace as 14, whatever you want. It's a little cleaner, I think, to have 1 to 13 rather than 2 to 14. But anyway, so cool. So let's do that. I was going to ask about that, right? So you guys are ahead of me. So yeah, so why do we need SRAM? So it's different each time, right? So I'm going to go to my, and I need C time for that, right? So I'm going to say include C time. And I'm going to just do that at the very start of my main. I'm going to say srand time null. OK, so let's try that. And we should. OK, so we get 13, 3, 11, 3, 6. We got 2 3s. We got a king, jack, and a 6. Pretty decent hand. Okay. OK. So the really cool thing, though, about having implemented this as using a vector is I can just make this a 7-card game now. So if I change make hand to 7 and we rerun it, now I have a 7-card hand. And everything just works, right? So I spit out a 7-card vector, and my print function also just works, right? Because it's just looking at the size. Questions so far? Okay, so the next thing I want to go through is actually, it's not really about this STL directly, but it's a fun little problem for us to solve together, right? So what I want to do now that I've got a hand is I want to identify a couple of things. I want to run through that hand, and I want to find out, I want to answer a couple questions. I want to answer, does it have a straight? Meaning that all of the cards in that hand are sequential, right? So we could have a straight starting at 2, for a 5-card hand would be 2, 3, 4, 5, 6, right? A straight for a 7-card hand starting with an ace would be ace 1, 2, 3, 4, ace 1, 2, 3, ace 2, 3, 4, 5, 6, 7, right? Right? So I want to detect straights. I also want to detect more than one of the same card, right? So I want to know, do you have 2 of a kind? Do you have 3 of a kind? Do you have 6 of a kind? You know, so what we're not doing, at least for today's example, is we're not actually, there's a lot of stuff we'd want to test. We want to make sure that, well, first off, the way I'm generating a hand is bad if this is actually going to be a card game, right? Because in an actual card game, there are limited numbers of each type of card, right? I'm not dealing with that at all right now. Not only am I not dealing with the suits, but I'm also not, it's possible, although unlikely, that we could get a 7-card hand with all aces. Right? There's nothing to prevent that right now. So, and that's something I would need to do if this is actually going to be a real card game, right? Okay, so I haven't said, we're just going to not deal with that today. So, okay, so now I want to do something. I want to have something that will tell me what's in a hand. So, and just to keep on with vectors, what I'm going to do is I'm going to write a function that will spit out a vector of strings. Now, why vector? So what these strings are going to be is they're going to say things like straight found from 1 to 7, or 3 4s found, or 4 10s found, or whatever, right? And it's possible that we might have 0 such things, right? Or we might have, realistically like 2 or 3, right? We could have several, right? We could have more than one. So I don't know in advance how many entries there are going to be. So I'm going to have a vector string. And I'm going to call it eval hand. And I'll take in a vector int hand. So I'll start off with a vector string. Let's call it results. And I'll return results. And, yeah. So now we get to talk about how do we actually do this, right? So what do you guys think? I want you guys to talk, at least a little bit. So we need to find a couple of things here, right? And I'll give you a little bit of a hint in that it's possible without using anything I haven't shown you guys. Right? So everything that we're going to use is stuff that we've talked about in class today or some other time. So we need to be able to recognize, so as a test case, right? Really simple test case. Let's say we're going to, we'll get to straights in a minute, but let's talk about 2 of a kind, first off. So let's say that we've got 5 cards, and we have this. We have let's say that's our test hand. So we have 2 2s, but they're not next to each other. They could be anywhere in that, right? It's randomized order, right? So how do we deal with that?
I would just say part 1, part 2, part 3, part whatever, and then I would check it to see if part 1 is equal to 2, 3, 4, 5.
Okay, so we could, take each card, right? And then compare it to every other card, right? But we also want to account for, so it's always good when you're thinking about how to solve a problem, it's always good to identify, if this is a big part of getting good at this kind of stuff, is identifying key test cases at first, right? So this is one test case, but we should also be thinking about a few others, right? So let's say that we've got this. So I think there's at least 3 we should be thinking about from the get-go. The case where we have 3. So let's say we have, so that's another test case, right? We have 3 of a kind. And let's also have test case where we have 2 pairs. So where it gets tricky, right, is that we could compare each card to every other card. Now that would let us know if there's a single pair, right? And that could be a good way to go if that's all we wanted to know. Like, is there one pair, right? Does a pair exist? But what we want to know a little bit more than that. And that we want to know for any combination, in any of these circumstances, right? We want to know how many of each type is there. So I'll give you guys a hint. There's something we could do to make all of these inputs easier to deal with. And we saw it today. Everybody got it at the same time. Awesome, yeah. So we're going to sort it first, right? So the problem is the issue that we get into really quickly, if we start, you should always be suspicious of anything that starts with, I'm going to compare every input to every other input. Because here it doesn't matter too much because we've only got 5 things, right? So if we compare each card to every other card, how many comparisons are we making? $20, right? Because we have 5, right? And then there's 4 other ones, right? So that's not that bad, right? But as that number goes up, it gets really bad really quickly. Because it's basically, if you've got n inputs, it's n times n minus 1, which is equivalent to n squared minus n. And it's this n squared that's a problem. So it's an issue, right? So we want to avoid that if we can. We want something that it just evaluates straight across, if we can do it. And one way to get to that is we'll sort it first, which is not a big deal, right? So first thing we're going to do is sort it. Okay? So now this is where we start to see how cool the STL is, right? So we haven't talked about sorting vectors yet, right? But what do you think? It's going to look exactly like what we saw when we sorted an array. Because that sorting isn't part of array, and it's not part of vector. What is going on instead is both array and vector implement begin and they implement end, which spit out iterators, which can then be used by sort. That's a little convoluted, but it's going to mean that we do the following. We say hand.begin and just to be clear about this, I'm gonna go ahead and just so we can see this happening, right? So I'm going to print hand, and then we'll sort it, and I'll print hand again. Right, so let's run that. Not. Oh, I didn't actually call eval hand, so okay. So I'm going to get rid of that, and what I'll do is eval hand. Okay. So now I'll run that. And we get current hand 7, 5, 4, 5, 13, 4, and then after we sort it, we see 4, 4, 5, 5, 7, 11, 13. Okay? And again, the key thing about the sorting, again, I hope I'm not belaboring it, but is it looks exactly like what we saw with array. And that's not because of array or vector. It's because of algorithm, technically. Upshot, though, is we don't have to do any of the sorting work. Again, I highly encourage you guys to read about sorting algorithms. They're really important. It's another thing that comes up in job interviews a lot, too. If people will ask you, run through bubble sort or whatever, it's often used. So let's, look into it. But using the STL is often a very good way to go. So I want you guys to be comfortable with that. OK, so now we've got it sorted. So we've got something like, this is now, let's see, 2, 3, 4, and 5. And this is that. And this is 1, 3, 3, 5, 5. So, OK. OK, so now what do we do? So I'll give you guys a hint, in that it's totally possible to figure out how many duplicates we've got by just running through straight from the start to the finish. So we can do it by just running through our list once. And we can totally know everything we've got. How do you think that might work? So to think about what's true in the case that we do have a duplicate. How can we define a duplicate? What is the case if there's at least two of a thing? Equals the previous one. Exactly. Right? So what we can do is we're going to start at the start of our list, right? Or actually, we're going to start at the second, right? Because it doesn't make sense to look at the previous of the first element, right? But what we can do is, for each element, we look at the previous one. If they're the same, we count up by 1. And we keep doing that, right? So we're starting here, right? We're starting here, rather. Start the first one. We say, is this the same as the previous one? It is, right? So we change something from 0 to 1. We found 1 duplicate. Now we go here. Is this the same as the previous one? No, right? But that variable that we were holding, we're counting up our duplicates, is not 0. We found at least 1 duplicate. So at that point, we know that we had at least 2 of a kind. So we process that. We do whatever we need to do with the fact that we've got 2 of a kind, which we'll see in a minute. Then we go to the next one. Is that the same as that? No. Is that the same as that? No. Right? So then we're done. Right? So over here, let's see how it works with 3 of a kind. Right? So we start, again, at the first one. So we can look at the previous. Is this the same as the previous? Humor me. Thank you. Yes. Right? So we take a 0 and we make it 1. Right? We go here. Is this the same as the previous? Yes. Right? So our 1 becomes a 2. We found 2 duplicates. Is this the same as the previous? No. Right? So then we can do something with the fact that we found 2 duplicates, meaning 3 of the same. So we'll do this in code in a second. But
What if 5 is the first number and 5 is the last number?
can it be?
Check the previous.
Well-
It's not, it can be a pair, but it's not previous.
Right. That's why we sorted.
Okay.
Right? So you're totally right that what I'm doing only works once it's sorted. Right? But it's totally valid because sorting is generally, at least if you're using there's a lot of good algorithms out there. And if you're using the STL, it's pretty reliable. So sorting is generally a fairly cheap operation if it's implemented in a good way, right? And it's generally something, you can get what's called in log n, right? So the way I was talking over here, we were talking about comparing everything to everything else. And I was saying it's an n squared thing. This gets to something called big O notation. So the order, meaning, the squared, right, is saying that, you take your number of inputs squared is the number of operations. That's generally really bad. You can have the order of log n, it's just sort of the inverse of that, meaning that, you'll only add more operations as you double the number of things. Anyway, so sorting is cheap and perfectly fine to do. Right? So we're going to sort it first. And I say it's totally right in that what I'm advocating for here would not work at all if we didn't sort. Requires that we sort. But sorting's easy, right? So what we want to do is go through and just for the sake of completing this, right? So if we do it here, right, we have 2 pairs. So we start here. Is this the same as that? No, right? So we're still at 0. Here, is this the same as that? Yeah, so we go up to 1, right? Is this the same? No. So, but we're holding a 1, so we process that. And we have 1 pair that we found, right? And we go here and we say, is that the same? It is. And then we're at the end, right? So we process whatever we're holding at the end. So let's look at how that actually works. So after sorting, I'm going to comment this out. So what I want to do is I want to have some comparison value, right? So there's various ways I could do this. And the way I'm going to do it is I'm just going to go ahead and set it up outside of the loop. And then I'm going to have my loop start at 1 rather than I could set it up in slightly different ways. So we start at 0. But personally, I like this a little bit better. So I'm going to call it last card. And I'm going to set it equal to hand 0. And I'm going to say for int I equals 0, I less than hand.size. Oh, and I'm gonna give myself one other variable. I'm gonna call it what do we call it? Duplicate count, and I'll set it to 0. Right. So that's going to be how I count to see how many duplicates I've found. Right. And if it's ever greater than 0, when I switch to a new number, then I know I had at least 2 of something. And I found a 2 of a kind, a 3 of a kind, maybe a 7 of a kind, whatever, right? OK. So what I want to do is I want to say, is the... you need to start at 1, right? Because, yeah. So what I want to do first is say, is it the case all right, so did we find something that's the same? I'm going to say duplicate count. Oops. Plus equals 1. Right? And that's actually all I'm going to do. So that's really simple. I just count up by 1. Because I don't want to actually make any use of that until I've stopped finding duplicates. Right? So that's when I want to do most of the work. Is not when I find something that's the same. I want to do the work when I find the first thing that's not the same. Because in this particular case, in the case of a poker hand, if we were only ever going to look for 2 of a thing, then I could do something here when I found the first duplicate. However, in the case of a poker hand, it's quite possible I have to be able to deal with 3 of a kind, 4 of a kind, and maybe even more than that. If this isn't necessarily poker, it's some other kind of game, right? So I want to do the work when we find our first card that's not the same. So in my else, now this is going to happen in one of 2 ways, right? So my else, if I've gotten here, it means that the card I'm on right now is not the same as the previous card. So there's at least 2 ways. There's 2 situations we can arrive at that, right? Either it's just a totally unrelated card, right? We've gone from like 3 to 5, and we haven't found anything. Or we've just ended a streak, right? So the difference between going from this 2 to this 3 with 3 of a kind, and going from this 3 to this 5 is what? How do I test for that? Something's going to be 0 or not. What's it going to be? What did I just increment when I found Well, we want to test it. So we're incrementing it here, right? So our duplicate count goes up by 1 every time we find a card that's the same. Once we find a card that's not the same, we test our duplicate count. So what I'm going to say down here is if actually, we don't need an else in this case, but so what we've got here is move to a new value, right? If we've gotten here at all. If duplicate count was greater than 0, found at least 2 cards of the same value. So we want to process some stuff there, but either way, no matter what, I want to reset duplicate count, right? So I'm going to set duplicate count to 0. Right? So anytime we go from a number to a different number, I want to make sure the duplicate count gets reset. OK. So now what I'm going to do is I haven't actually done anything here yet, so I'm just going to print it for now. We'll get it wrapped up in our string vector in a minute. But I'm going to say found and I want to say the actual value that we found, right? So last card, and I'll add an S and new line character. OK, so that will successfully detect X of a kind. So let's try it. There's a small error. Does anybody see it? There's something in the print statement. It's not a bug. It's not gonna prevent compilation or anything. But it's going to give us a weird result. It's probably not what we're expecting. Anybody see it? OK, let's just run it, and we'll see what we get. All right, so one thing we haven't talked about is explicitly setting the value of vectors, right? So I'm going to make a new vector just for testing purposes. And I'll put our inputs that we had on the board. So I'm going to say 2, 5, 2, 3, 4. I think is what we had. Something like that. So we had 3 and 5. Yeah, OK. And vector and test 3 equals, what do we have? We had a 2, 1, or let's say 3, 1, 5, 3, 5. OK, so I'm going to eval hand test 1. OK, so it detected a pair, but I see found 1 2s. Not quite right. Where'd I go wrong? Exactly. Yeah. So duplicate count needs to start at 0. I mean, I guess we could. There's sort of 2 ways we could go about this. We could say that our sort of default value is going to be 1. That's not what I would do personally, because I've been programming for a long time, and numbers start at 0, right? So what I would do is I would just add 1 here, right? So that's what I'm going to do. So that makes more sense conceptually to me. To have our default value be 0, and to just add one when we want to talk to humans about it. But just for the sake of saying it, it would be equally valid and work just as well to set the default of duplicate count to 1 and just test this to see if it's greater than 1. That would work too. So I like it this way, but that's me. There's often more than one way to do something. All right, so let's try it with input 3, right? So far we've tested it with a single pair, and it seems to work, right? So we get found 2 2s. So awesome, cool. So let's throw other stuff at it. So eval hand test 2 and eval hand test 3. Oh, and just to keep things a little bit clean here, well, not clean, but just make it easier to see, I'm going to output some extra stuff here. OK. So let's see how we do. OK. So we're getting close, right? So our first test, we found 2 2s. All right. Well, that's pretty good. Our second test, we found 3 2s. All right. So that's good, right? But we didn't find anything here. What's going on with that? OK. Should have found the first one. But all right. So one of the things that we're not doing is when you get into this is a fairly common sort of thing to do. I've done this in a lot of different contexts, in a lot of different ways, right? And by this, what I mean is I've got some list of things, right? And I'm processing them, starting at the beginning, going to the end, checking for some sort of criteria. And that criteria is in some way dependent on other elements in the list, right? So I'm comparing them kind of to themselves. I'm looking to see if I've got multiples of a given thing, et cetera, right? So each step through, I'm looking sort of to the back a little bit, right? It's totally fine. But the problem is, one of the things that's going wrong here is I get to the end and I'm not running this code, right? So this code here is what actually takes notice of the fact that we have a duplicate, right? So if I'm going through our array, each step through, right, I check against the previous. But if I get to the end, so here, right, if for these 5s, I had this was a new number, right? So I was looking at 3, and that was not the same. So that ran that code, and it just so happened the duplicate was, sorry. So I get here, though, right? And I've upped my duplicate count to 1, but then I get to the end of the array. So what I need to do is I need to run that check one more time at the very end. So outside of my for loop, I'm going to have that same code. Because when I get to the end, I might still be holding one last result. I have to make sure I check for that too. Again, this is a really common sort of thing to get into with programming in general and game programming especially, where you're running through some list, checking it against itself in some way, and it's really easy to end up missing the last result. Because you've got some logic that's going on inside the for loop that also needs to happen at the end of the for loop too. So, and I'm not sure why we're not seeing the